Hello, everybody. I'm Matt Yakovit, head of open source strategy at Percona, and I am here for OpenUK's Summer of Security series. Today, we're talking with Liz Rice, who's the chief open source officer at Isovalent. Hi, Liz. How are you doing today?
Hi, yeah, I'm good. Thanks for having me on the show.
Well, it's glad to have you. Glad to have you. Amanda wanted us to connect and chat a little bit about all things in the security space. But for those who are new to open source and maybe new to your role as chief open source officer, I was wondering maybe if you could give us a little introduction and tell us, what does a chief open source officer do?
It's a great question, and actually particularly interesting because the company Isovalent is very much built around an open source project, which is Cilium, quite well known in the Kubernetes world for networking and observability and even some security aspects, which I'm sure
Ooh,
we'll talk about. Um, so when I joined, it was already a very open source focused company, but a big part of what I do is around the open source community. Um, I get into sort of debates about whether I like terms like advocacy or developer relation. I definitely developer relations feels weird when it's not just about developers; it's about users and other kind of contributors. So a lot of it is about community, but also the strategy side. I mean, you have a head of open source strategy title, and I think that is, there's an element of what I do that's very much around how do we make the most of our experience in that open source project to build a successful business, because can't all just be about free software. It also has to be about writing paychecks.
what? No. Well, yes, I do like to get paid. Yes,
Yes.
I do. I
Yes.
do that. So, yeah, it's definitely an interesting space because when you do hear open source, you often think free. Many people associate free with open source, and they don't necessarily think that, that there's a monetary business behind it. But in reality, there is. There's lots of businesses right now behind open source projects. So, it is an important distinction for sure.
And
So,
we've seen so much growth in companies open sourcing projects or collaborating together on open source projects. And I think that's a really healthy thing for innovation. And, you know, alongside, they're also running healthy businesses. And I think that's brilliant.
yeah, and part of the challenge with a lot of smaller companies or projects that don't have the financial backing of necessarily companies is they're often doing open source as a labor of love, and it means that bugs tend to linger a little longer. Maybe there isn't the focus on the testing or some of the usability side of things. So it does benefit. I mean, money does have money is the root of all evil, as they say, but it does have some benefits when you're trying to run an open source project and really collaborate in the open source space. It does help you focus your efforts and spend your resources in certain areas.
Yeah, for sure. I mean, I think a lot of the reasons why people are using open source software, it's less about the fact that it's free. It's more about the fact that they can try it for free, they can experiment with it for free. Um, and importantly, it's open, it's not under the control of one particular vendor who maybe they're not going to be around in 5 years' time. If you're a large enterprise and you want to use some infrastructure software or even some security software, a lot of the time, knowing that the software could outlive any given vendor is, I think, really that it's important. Businesses want to be able to pay for support, but they also want to know that the project is going to have a long life. I think
Oh
that's one of the
yes.
really interesting roles of foundations, actually.
Yes, and I mean, it used to be when you bought proprietary software, you, as a big business, you would negotiate to put their source code in escrow. I don't know
Hmm. Hmm.
like if people listening remember that, but I remember, like, I worked at a large Fortune 500 company way back, and they would negotiate with vendors to say, well, we don't know if you're going to be around in 10 years, so we want your source code in escrow in case you go out of business.
Yeah.
Which is, it's a weird thing to think about that now, but that used to be a very big concern, And now with open source, it's mitigated quite a bit because a lot of companies have picked up the mantle after open source projects have, either dried up or founders or the teams behind them decided to go on and do something else.
Mm, mm. Yeah, or the company gets acquired and the acquiring company no longer wants to invest in that project. That's,
It
these things
happens.
do happen. Yeah.
Yeah. But does that lead to the potential for security issues when you have software that is in the open source space? It's available to everyone, so everyone can see the source code. They can see the gremlins lurking underneath. So there's a question: is open source more secure by default than proprietary, or is it just more visible?
Hmm. Yeah, it's a really great question. And I think visibility doesn't necessarily mean that people are actually looking.
Ah,
So
yes.
we could take OpenSSL as a really great example. There's been a CVE just in the last few days, I think, and there was historically, there've been some pretty serious ones in the past. And it's not that the code wasn't open source, it's that there wasn't a community who understood the code. It's complicated, and if that one person who's expert enough to kind of know about it is just didn't notice that particular issue, if nobody else is paying attention, it's gonna sit there forever. That said, the same is true for proprietary software. We just can't see it. We don't
Right.
know about the CVEs that are in proprietary software. So my assumption is that all software on average is the same, whether it's proprietary or open source, except that you do get more eyes on the open source project, or you can have more eyes on the open source project. The question is whether or not people are really reviewing it, whether people are really testing it, taking it to the extremes that will show these. And actually, I think this is why CVs are getting found, because people are doing that kind of really tough testing that
Yeah.
shows problems.
Well, so it's interesting. So you brought up a couple of interesting problems or topics to potentially dive into. One of them is specifically, you mentioned, OpenSSL, uh, and its small community. It is amazing how many open source projects rely on open source libraries, open source projects, the tree, if you will, of
Yes,
software that they rely on. And many of these projects are using software that doesn't have a very large community. They might be really widely adopted, but they might not have a large cadre of collaborators.
indeed. Yes. We can look at NPM for some examples of that, I think.
Well, yeah. So, and this is where it's super interesting because you can have you have these different libraries, these different pieces of software that are so prevalent in our society now across proprietary and open source projects alike make use of them. And you know, having one or two people who are responsible for those projects, you don't get the visibility into security issues. You don't get the visibility into, bugs or features because maybe nobody runs into them. Maybe they're not pushing the limits, but there's such a few number of people. But
Mm,
even secure projects end up, relying on them. And it's weird because it's not generally it's this what they call the supply chain issue, I guess, right? So it's the secure,
yeah,
the open source supply. Where is your software originating from, and can you track all of the software that's in it? The software bill of materials, they call it, right?
yeah.
Where you're trying to understand the origin of this particular piece of software, but it's really really complicated because I can, at Percona, we do, for instance, like MySQL, Postgres software. We can we would focus on the MySQL side, but there might be all kinds of other stuff that MySQL relies on underneath that we might not be experts on, or those pieces of software might rely on a different piece of software, and that software might rely on a different piece of software, and you start to get 10 layers deep, and it gets really complicated really really quickly.
Absolutely. Yeah, yeah. And you can end up with i- different libraries depending on different versions of the same software potentially. This is the whole
Oh
kind of
yeah, yeah.
containerization challenge, or the reason why containers came about was to fix that challenge from a just importing the right version
Uh,
point of view. But you then have the kind of challenge of making sure that your dependencies are updated. uh, All these different versions that you might be using in a given distributed system, when any one of them has a significant security fix that that dependency needs to be updated. It's a big deal. Yeah.
so, in this type of an environment where we have lots of open code, lots of open software, but it's relying on many, 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 many different projects or libraries, it seems like there's an infinite number of potential attack vectors.
Yeah, probably. Yeah.
What can we do? Like, do we just like well, what sort of things should we be paying attention to try and keep this infrastructure secure?
Yeah. So, eh, I mean, you've mentioned this software bill of materials, the supply chain uh, challenge. That I think there's some interesting projects working on things like Sigstore. Um, you know, being able to have that inventory of what you're actually using, what those dependencies are, and knowing that if you import a library from a certain place, that is the trusted version of that library and hasn't been tampered with. Um, and then there's also the kind of dependency scanning. My previous employer was involved in that, and one of the projects that uh, they at Aqua look after is Trivy, which is a vulnerability scanner, and it's a really it's a complex challenge getting this CVE information in kind of lots of different formats, and a lot of it is maintained in different ways, and figuring out which CVEs are actually present in any given dependency. It's more complicated than you kind of think it might be at first glance, because you have things like different patched versions of the same library used by different Linux distributions, for example. They may have different approaches to um, how they apply those patches in the versions that they distribute, and then that makes it really hard to say whether or not if a CVE is found in version 3.0, but you're running 3.0 patched with such and such, you have to know whether the patch includes that fix or not.
Hmm. Yeah.
Keeping track of that is a pretty complicated challenge.
Well, so this is where there's been a lot of discussion around like certified repositories, right? Or like Google, for instance, is talking about well, we'll provide you with you know binaries and with packages that are patched and guaranteed to to meet certain quality requirements. But I've heard that from some other places as well. But it sounds kind of like we've gone away from getting everything out of your Red Hat repositories, if you will, like going to the rel network, and then we've gone to everybody just grabs everything off GitHub or Docker Hub. They're just going to grab containers, and now we're like, ooh, that's bad. We need to go back and we need to have like an official place to grab our software to make sure that it is somewhat secure, and it's not going to run any sort of vulnerabilities, or even like have any sort of protestware or um,
Mm.
bad actors in the middle.
Mm. And you do see sometimes in very high security organizations, they're not necessarily prepared to trust something that has been built by somebody else. And I, don't know what criteria they would necessarily choose to say whether or not they would accept, for example, the Google binaries. But they want to have the source code, and they want to control the build tool chain and be completely confident that you know the tool chain itself is something that they have built, so that the, I don't know, compiler doesn't
Hmm.
inject some kind of malicious code. You can go quite a long way down that.
Yeah,
You
and I'm
might
like,
what might sound like paranoia, but I think if you're really trying to protect against serious attack, you may have concerns about how things are built.
yeah, I mean, I think you're right. I mean, you might have those worries about how it's being built, but I wonder if that's more secure or less because I mean, just logically, I think that if you're getting your software from a trusted source, I mean that's great, and I mean you're going to eventually have to trust someone. But is anyone really going to go through all the code? Like I mean, like really?
Yeah, yeah.
And
I often wonder. I've never worked in you know, let's say a government agency, and it would be really interesting to know what level of detail they go to inspect dependencies.
well, so we've seen like the rise of kind of like you can call it protestware or nukeware or whatever, where people have actually introduced malicious code for either social causes, protest against war, or just because they didn't get paid. In the
Yeah,
case of like some JavaScript libraries lately, I think that you would need to understand what was introduced, and you would need to really look through that source code to uncover those.
yeah, yeah, for sure.
I
Yeah,
mean, and that could be a potential big issue, right? But anyways, it's a weird thing when I
yeah.
hear people who, yeah, we're going to build from source because it's more secure. I don't get it. I don't understand it. I don't necessarily agree with it. Doesn't mean it's wrong. I just might be uneducated in that.
I think it becomes a question about the you're starting from source code that you can inspect versus a binary that is hard to
Mm,
inspect. And whether you do or don't inspect it, at least you can, and you can look at the change history, and or you can also look at things like what is the approval process for changing that source code. If a given repository allows one individual to just make
mm.
changes without review, that's probably going to be easier to compromise than if you have some process that requires
Yeah, I mean, I
n.
get it. And maybe there are people who are deep diving into the source on a regular basis to ensure that. My gut says that a lot of those folks are probably just letting it go and just having it just in case, which
Mm,
probably means it's no better or or worse than the other, except for the resources used. But
mm,
that's just
mm.
my opinion, which has been known to be wrong on more than one occasion.
There was
So,
that famous case where some, I'm going to say research students, but
University of
when
Minnesota and
they
the Linux kernel.
exactly, yes,
Yeah.
yes, and kind of proving that, or their claim was, we have proven that you can compromise the Linux kernel in this way. Um, yeah.
Well, I mean, but this is why, like, so you see, like, big companies that have large fleets of software will run very old Linux kernels and very old
Mm,
versions of software because they have gone through a very thorough test of those environments and they know any potential vulnerabilities, but they also know, what to expect and they have limited, what's available in those custom builds. And so they might be 5 years out of date in terms of features, but they, make sure that it's very tightly controlled.
yeah, and actually, in terms of the time it takes for a kernel version to make it into, even common enterprise distribution, Red Hat Enterprise Linux is using a kernel that I think is about 5 years old now. It's pretty typical that it's a few years of field hardening, you know,
Oh
um,
yeah.
and so it's not just the organizations who have some special security requirements. It's just a very common pattern in enterprises to use these old versions of the Linux kernel, which I kind of come across because a lot of what we're doing now is eBPF, and eBPF has been able to suddenly take off because we're suddenly seeing enterprise distributions that are new enough to support eBPF capabilities,
Yeah.
and yeah, which is pretty exciting to me.
Well, so speaking of eBPF, for those who aren't familiar, maybe give us a brief overview.
So the acronym stands for Extended Berkeley Packet Filter, but I advise everyone to just forget that because it's about so much more than packet filtering now. It's kind of become a name in its own right. What eBPF allows you to do is run custom programs within the kernel. So you can load programs into the kernel, they get triggered by events, and you can change the way that the kernel behaves. So those events could be, well, anything really. You can trigger off any function in the kernel or, in fact, in user space. So I think initially we saw a lot of use for observability tools, tracing tools. Let's count up the number of times that people opened a file, or let's send a notification every time somebody opens a socket, or um, that kind of thing. Let's count up how many packets have been sent over the network. Um, Kind of in parallel, the Cilium project was using eBPF. So a lot of the folks who work on Cilium have been involved in the eBPF development in the kernel as well. So using eBPF as a networking platform. So
Hmm.
rather than going through the kernel's networking platform or networking stack rather, in all cases, using eBPF programs to shortcut the route from, let's say, a network card to a particular application, or in the Kubernetes world, from incoming packets routed straight to a particular Kubernetes pod. So yeah, eBPF is a really interesting way to get custom or bespoke behavior in the kernel dynamically. The other thing that's cool about it is you load a program and it starts taking effect immediately. It can see, the whatever events it's attached to, even if the process that triggered that event was already running, your eBPF program can see it because that event is still being triggered. So you get this incredible visibility over things that were already running before you started your eBPF based instrumentation. And it's super performant because it's in the kernel, and you don't have to worry about things like, well, you only have to transition between the kernel and user space if you want to send data from kernel to user space or vice versa. So there's pretty pretty good performance, amazing new capabilities that we're seeing built on eBPF.
Yeah, we've used eBPF for a while on performance tracing and
Mm-hmm.
finding, the oddball problems.
Mm.
Uh,
Mm.
but I've seen that you have recently been doing some talks on using eBPF to diagnose and find security issues.
Yes, yes. So Cilium has some track record in using eBPF for security purposes on the networking side. We implement network policies using eBPF. And in that case, you're essentially looking at a network packet and deciding if it's out of policy, then we will discard that packet. And then it can't, you can't send a packet to an out of policy destination because it's just been thrown away. More recently, so we've seen there's actually quite a long history of eBPF being used for security tooling, starting with SecComp. It's actually more like BPF than eBPF in this case, but SecComp, which is used to have a profile of what system calls a given application's allowed to make. It's actually a BPF program that's evaluating for each syscall, like, is this syscall in profile or out of profile, or in policy or out of policy. So very simple BPF programs there, but that SecComp's been around since, I don't know, 10 years, probably longer.
Yeah, yeah, yeah.
um, and then people started building tools that kind of hook into the same interface as a lot of the observability tools. Um, and I probably be going a bit into the weeds to worry too much about why that isn't necessarily. No, I will talk about it. So yeah,
Oh, it's
when
fine.
you
It's fine.
yeah. So when you make a system call, um, there's this sort of observation point that a lot of tools have used that says, okay, I can see the system call is being made. Perhaps I should, you know, make a decision about this, whether this is malicious or not. And building on what you can do with setcomp, you can look at the actual parameters and you can say, oh, this application is trying to open that file. Do we think that's okay? And the problem is that if you look at that parameter before it's been copied into the kernel's data structure, there is actually a window of opportunity for an attacker to change the parameter before. So, what the kernel acts on isn't necessarily what you thought you were seeing when you looked at the system call. So, to avoid that, you have to make the checks or you have to attach your eBPF programs after the kernel's got that parameter information copied into its own data structures. So you're looking at the data structure as it's about to be acted on by the kernel. And in fact, this is exactly the same approach as Linux security modules. So things like AppArmor, SE Linux, they use an API in the kernel that is made up of these function calls that happen after the kernel has copied parameters from user space, and before it does actions, there are these function hook points that you can write a security module, a kernel module to enforce. But now you can do that with eBPF programs. You don't have to have a kernel module. You can dynamically load eBPF programs to look at these kind of hook points. The only problem with that is that much like I was just talking about how eBPF is has been in the kernel for long enough that it's now in versions that people are using pretty commonly. This ability to attach to the Linux security module interface is still pretty new. So that
Okay.
part hasn't necessarily been rolled out to everybody in production. But something that we've been doing in Cilium in a security project called Tetragon is saying, well, we don't have to use that official Linux security module API. There are plenty of other places in the kernel that they're not declared as stable. They could change in the future because the LSM API is not going to change. It's part of the kind of guarantee that it's not going to change. But there are plenty of other functions that are in the right place, haven't changed for a long time. There's no likelihood that they're going to change. And even if they do change, there will be some number of years before those changes roll out to production environments. So we can hook into these functions in the kernel using basically knowledge of the kernel to hook into the right places and make these security checks in a safer way, which is really I don't know. I find this all sort of fascinating. I find it really interesting that we can, run these security checks within the heart of the kernel, and it's literally changing whether or not the kernel will go ahead with that activity. It's pretty
Well,
exciting.
and I think the lower level that we can get from a security check perspective, the better off we are. Because as we mentioned earlier, there's so many different attack vectors now because when we look at the breadth of the different libraries, the different pieces of software, the amount of code that is involved in any single application now, there's a lot of potential vulnerability attack vectors. So the lower we get, the easier it is to detect when there is some anomalous behavior. Um, because it's very difficult at the very top of that setup to say, oh, we've got 10,000 libraries that all are used within this one application.
Mm.
Which ones are secure? So I think the lower we can get, the more secure we can make things.
Yes, I think there's a lot of focus on that kind of pre-deployment security. So things like dependency management and scanning for vulnerabilities, which is incredibly important. But the runtime aspect, that ability to say, But I know that, no application should ever be contacting a cryptocurrency miner. That kind of thing that can be policed in
Yeah.
real time, is very powerful and makes a lot of sense. I think we're still there's still a bit of a gap in tooling between the developer's understanding of, like, okay, I've written an application and I know it should open this file, that file, talk to this database, and receive messages from this set of IP addresses or domain names or what have you. And a developer will probably have a pretty clear picture in their head of what those kind of activities are. Translating that into security profiles that can be enforced, to me it makes a lot of sense that, particularly if we're talking about a microservice, you should be able to write a profile that kind of matches, you know what expected behaviors are. What's my application going to do when it fails? Even, well, it's going to send logs over here, and even the error paths we should be able to reason about. So I am hoping that we will see tooling develop that makes it easier for developers to kind of express that knowledge in security profiles. So security isn't making a guess about, like, which network connections are acceptable, or and we see that increasingly. We see that with things like service mesh, where people are enforcing which services can talk to which other services. Um, so we're moving in the right direction, but I would love to see us get to a point where people's knowledge of what expected behavior is can easily be expressed and enforced by security tools. That's the direction I think we need to go.
Yeah, and I think this is all about defense in depth, right?
Yes.
So very important that you have the tooling, you have the processes, you have multiple layers where you're not only looking at enforcing what sort of software you're ingesting and using, what services you're subscribed to, but you're also building the tools to catch everything if those even fail. I
Yes.
think that's really important. But
Yes.
it's interesting. We talk a lot about vulnerabilities in software or malicious actors exploiting CVEs, but there's quite a few quote unquote security issues that are caused by none of those. They're caused by just people using software they don't understand, misconfiguration or leaving things open. I equate it to you have your house and you build this elaborate alarm system on the front door, but you leave the back door open, right?
Yeah.
Those types of things happen probably more often than the CVEs are exploited, because it's so easy just to ignore or forget or just not understand how things should be configured or set up.
Absolutely. Humans are incredibly fallible, and people are bound to do things like, I don't know, inadvertently blurt out their password on a podcast or something,
So live streams now, you got to be careful when you type in the passwords on a live stream or connect to things, right?
Definitely, yeah.
Yeah.
Yeah, or just types. I mean, we've seen this with not so much security incidents, but kind of operational incidents where people have made a change to, I don't know, some routing tables, and it's had a terrible effect that is hard to roll back. And you can just imagine the person who's typed it in, as soon as they've hit the return key, kind of thinking, yeah, that was a mistake, I shouldn't have done that. And you can't always roll back something once you've typed it in.
Well, yeah, and I mean, especially with the way that everything's automated now,
Yeah.
one wrong step cascades the problem of 10,000 times.
Yeah, yeah. Which is where, from a security perspective, you come back to that defense in depth idea, that the more opportunities you have to catch something that's gone wrong, the better. I have had conversations with um, developers who've kind of not quite, when we've talked about the hypothetical of a particular security escape, and they've said, yeah, but I don't understand how we can have got into this position in the first place for this attack to be a problem. Like, well, Yeah, maybe somebody just did something really stupid, and that's, it's the idea of things like uh, security issues that could affect a container running with like extra privileges, or a container that's mounted in some sensitive directories from the host that it's running on. And people go, yeah, but that should never have happened. Why do I need to defend against those issues? Well, because somebody will do it because you can, and they might not have meant it maliciously, but they'll do it.
Oh yeah, yeah. I mean, we live in an age where everyone's data has been breached a dozen times or more, and a lot of them are caused by those simple things. It's not some malicious actor. Whenever you get down to it, it's someone who forgot to set a password, or they took a backup and they left it unencrypted and left it in an S3 bucket, and somebody you know pulled it down.
Yeah,
All those things happen so frequently, it's not funny.
yeah, yeah, for sure.
And I think part of this is driven by the amount of microservices, the amount of data, the amount of different things that we're deploying. I mean, let's be honest. 20 years ago, it was a big monolithic application that had, a web server, an app server, and a database server, and that was it, right?
Mhm.
Now we're talking about, everything being deployed via containers in Docker and Kubernetes, and with multiple, services, external and internal. And if you look at an application diagram now, it is so much more complicated than it was not too long ago.
And also just collecting so much more data,
Oh,
whether
yes.
that's, Internet of Things, edge devices, the construction of these giant data lakes of data so that we can do things like, you know, AI, machine learning, or, we're collecting so much data. And I think that has changed the way we need to view some of these, you know, security challenges, even
So
in the last decade.
how do we handle with that sprawl with so many things that we have to look at and secure? I mean, observability obviously is critical, but what are some other things that we should be looking at?
Oh, that's a really great question. I mean, I think it's going to come back to that defense in depth, that there isn't going to be just like one solution, but there's going to be layers of, tools that do observability and inspection, and policing policies that, we need to get better at. I think, we even get into challenges that touch on other aspects of engineering. If you have a large enough amount of data, then it starts to become challenging to use that data, because you've got to find the useful bits out of that giant pool of data. And how do you uh, how you manage that data? How you can't, moving data around becomes a challenge. It becomes a physical challenge to move large amounts of data around. I think there's a a lot of engineering questions that weren't necessarily asked when people first started thinking, you know what, we should just collect all the data. We don't know what we're going to use it for, but we'll use it for something in the future. And while we're figuring out how to use it, that data is sitting around and potentially could be abused in some cases. So, yeah, it's a challenge.
We are digital pack rats. We are. We
Yeah.
are.
Yeah.
That want as much data as possible just in case, right? So
Well, yeah.
but as we've grown these systems, new tooling and new technologies have started to become de facto standards. And obviously, one of the big ones, and since you've written a book that's behind you, container security from O'Reilly, the next iterations would be Kubernetes, right? Security, and how do we secure Kubernetes? And it's funny because I hear from a lot of folks Kubernetes is insecure by default,
Yeah.
and you should just plan for it to not be secure. Um, and on top of that, because of that insecurity, I have seen more companies, startups in the Kubernetes security space than ever before. I was just at the open source summit a few weeks ago, and there must have been like 50 companies that
Mm.
we secure Kubernetes, we secure
Mm.
Kubernetes. So, what about security in the containerization space, but not just containerization, but in a Kubernetes environment?
Mm, mm. It's it's funny that you mentioned my book where I focused on container security, even though at the time I was already, doing quite a lot of things in the Kubernetes world, but I could see the security world changing so quickly in Kubernetes that I thought, you know what, there's plenty that we can talk about just if we stick to the kind of container level, the runtime and the images. So, you know, I didn't want my book to be kind of out of date as soon as I'd published it. Where I think if I'd covered Kubernetes at that stage, it would have been pretty, a time limited book. Um, there are some great books now that Kubernetes has sort of evolved a fair bit with some of its security model. Um, yeah, it's not secure by default, but a lot of the defaults have improved. I mean, you know, back in the day, there was things like the API server would be open by default. So, if you can send a message to the API server, that's the equivalent of having root access. And people were just standing up Kubernetes clusters on, with that API open to the internet. And yeah,
Okay.
it's, we've moved on a long way since then. Um, yeah, it's but there are some aspects, for example, running containers as root. People kind of have this funny idea that I've been trying to disabuse them of for years and years and years, that if you run a container as root, yeah, but it's only root in the container. No, by default, that is root on the host. And you're constrained to this view of the container unless it's been badly configured or unless there's a container escape. And if you get out of that container, you're root on the host.
Mm,
if you have access to, somebody mounted a sensitive directory into your container from the host, you your root, you can modify those files even if it's the password file on the host.
yes.
Game
Yes.
over.
And if you have root, then security doesn't matter anymore.
Oh, right. Yes, exactly.
Yeah.
That
Yeah.
it is game over. Yeah.
Yeah. So, Liz, let me finish with this question. So, as you look forward to the security landscape, you look forward to what's coming down the pipeline. What do you see that either has you really interested or maybe concerned from a security standpoint in the open source space?
Well, I think it's very exciting that there is this effort going on. A lot of smart people are working on that supply chain challenge and signing. So I think that's a, a huge step forward. And just the very fact that people are taking security more seriously, um, getting things like security audits done, it has become a much more common thing. So, for example, in the CNCF projects automatically get a security audit from an independent third party before they can graduate, because people have really seen the value in having somebody come along and try to poke holes in it, try to find the ways that that project can be compromised. uh, so those are all good things. I think also on the eBPF side and on the kind of kernel side, there's uh, a similar set of challenges around making sure that if I'm going to load an eBPF program into the kernel and it's going to change the way that machine is going to behave, I need to know that that program is trustworthy, because
Yeah.
could be doing literally anything. So similar initiatives around signing um, are happening at that level as well, which I think is important. Um, it's always going to be an arms race, though. We're never going to get to the end of this. It's never going to be a solved problem.
Right. Yes. So you're right. And I think that that's where um, there will always be the next challenge, but there's also the next opportunity,
Yeah,
right? And new things to learn and new things to explore. And as we start to evolve as an industry, we're going to find that there's new tools, new challenges ahead. But that's what makes life interesting.
yeah. Yeah, and like you mentioned, there's a lot of companies finding interesting challenges that they can solve in the security space, and they're building businesses around that, which is, I think, all part of a healthy ecosystem. I'm sure some of those projects and products are better than others, but it's good that it's vibrant. It's good that you do have choices around security tools.
Well, Liz, thank you for coming on and chatting with us. Thank you for participating in the Open UK's Summer of Security series. I'm sure that this will help quite a few folks who are thinking about open source security.
My pleasure. Thanks for having me.